Okay, now children, moving to the chemical properties of sulfuric acid. Now in the second point we'll be seeing that how sulfuric acid is acting as a dibasic acid. So when we talk about dibasic, children, means what? That its basicity is 2. Okay, di for 2 and basic is the basicity. Now what is basicity, children? It is the number of hydrogen ions that will be generated whenever the molecule is going for dissociation, and of course the dissociation is possible only in aqueous solution. So that is the basicity. So when we talk about dibasic, children, that simply means what? That this sulfuric acid that we are having, this when goes for dissociation, and it will dissociate only when it is in water. So it will be giving me H plus and SO4 2 minus. So how many H plus ions it is giving me, children? 2. So that is why it is considered as a dibasic acid. So even this question can be asked, that why is sulfuric acid called a dibasic acid, and then in the steps just write down that how is basicity equal to 2, and then or else how are the hydrogen ions liberated. Now this is the final equation which is there, children, that is telling you that how is hydrogen ions getting liberated. But then when you talk about the proper steps, what happens? H2SO4 does not release to hydrogen in one step. So in the first step what happens? This H2SO4, this goes for dissociation. Of course this is a reversible reaction, and then what happens? H plus is formed, and along with that this is HSO4 minus, means what? Initially only one hydrogen is being liberated. Now if I talk about the second step, this is HSO4 minus will be giving me what? It will be giving me again H plus and SO4 2 minus. So whenever they are asking you write down the reactions of dissociation of sulfuric acid, you will have to write down these two steps, and then finally what you can write down, that this is the way it is getting dissociated. Why? Because, children, what will happen if you just add up this? What will happen? The HSO4 from both these sides, they'll get cancelled up, and the net equation will become what? It will become that H2SO4 is giving me 2 times of H plus ions and SO4 2 minus ions. Alright, so this is the way this equation is being formed. So moving on to the further step, children, what is happening? See, in this case dissociation that is there in 2 steps that we studied already, and now we will be moving to the next point, that it is forming 2 types of salts with water. Okay, so since it is a base, so it will be forming, whenever it is reacting with an alkali, then it is forming different types of salt. Of course you always know that acid and base, when they combine, they will be forming salt and water. This is the reaction which is there, a general reaction. So what is happening now? When sulfuric acid, it is reacting with alkali, it is forming 2 types of salts. The one will be acidic in nature, and another will be a neutral salt or a normal salt. Okay, now what is the example of an acidic salt? So for acidic salt, the example that has been given is only when NaOH that is there, that is our base, okay, sodium hydroxide, when this is being reacted with sulfuric acid, we are getting what? We are getting NaHSO4. This is NaHSO4, and then we'll be getting water. Okay, so what is happening here, children? You can easily see that the NaOH which is there, that is in a sufficient, not in a sufficient amount, it is present but not sufficient to form a normal salt. So whenever a limited quantity of NaOH is being added to H2SO4, it is giving me NaHSO4, and the nature of this salt is acidic. So this is termed as acid salt. Okay, this is sodium hydrogen sulfate. So as you can see, we have salt over here. So this is an acid salt. This will be showing an acidic character. But then when I am taking this NaOH in a sufficient quantity or in an excess quantity, then what happens, children? The salt that is being formed is sodium sulfate. Okay, so this is being formed Na2SO4. So we all know that sodium sulfate is a normal salt. So just you can see the same base, if we are limiting the quantity or if we are taking the quantity in excess, that is responsible for changing the nature of salt. If the limited amount is taken, then it is forming an acidic salt. If a excess amount is taken, then it is forming an normal salt. So you can be asked a question of this type, children, that what is the nature of salt that sulfuric acid is forming on reaction with the base in excess quantity or in a limited quantity. So this is a question which you can expect. So here, or else write down the reaction that will be showing that sulfuric acid is a dibasic acid. So in that you will be writing this particular reaction that we just discussed previously. Okay, now we will be moving to the next part, children. So if you just look at the next part which is there. Okay, now this is the thing, sulfuric acid as a least, okay, or a non-volatile acid. So when we talk about least acid, children, what does this mean? That in comparison to other acid, okay, when we talk about least, it does not mean that it is very less acidic or it is not at all volatile. No, it is there, but then when we compare it to other acids like our HCl, you all know that HCl is very reactive, and then we have, when we talk about nitric acid, that is our HNO3, then what happens, children? Compared to them, it is less volatile. Okay, so when we talk about less volatile, then it is what is happening, that even if it is getting volatility, it is getting at a very high temperature. Okay, so what is happening? Hence, on heating with salts of more volatile acid, concentrated sulfuric acid displaces the volatile acids from their salt. So this is the reason. So what can you be asked, that why sulfuric acid just replaces the salts of more volatile acids? Okay, so these are the things that you can be asked. Then what will you write? See, here in the reactions what is there, so what are we concluding? That H2SO4 which is there, it is less volatile as compared to HCl and HNO3. And then it is least acid. When we talk about least acid, means acidity compared is less. So what are we seeing here? The salt of volatile acid is NaCl. So NaCl is a salt of what? It is a salt of base, and then it is a having chlorine it with. So it can be what, children? That the hydrochloric acid must have acted to form NaCl. Now what is happening when H2SO4 is getting reacted it with, and you can see the temperature has to be greater than 200 degrees Celsius, because sulfuric acid, it is acting as a volatile acid only when it is given a high temperature. Okay, so what is happening, whenever NaCl, it is being acted with H2SO4, first of all, whenever the ample amount of heat is being provided, it is forming NaHSO4, this we have seen, and then it is forming HCl. Means what did this H2SO4 did? It just replaced the SO4 ion which were there, they just reacted with the NaH. Okay, so here what happened? NaCl became Na plus and Cl minus. Okay, and then what did H2SO4 become? H2SO4 became H plus and HSO4 minus. Now this HSO4 minus, it reacted with Na, so it formed NaHSO4, and then what was left is HCl. So NaCl was a salt which was formed from HCl, but then what is happening? Concentrated sulfuric acid is just replacing here Cl, and then whatever is being formed is this. The base, what we are getting at the end is the starting product from where the salt was being formed. Similarly, if you see here KCl, it must have been formed from, again, of course, the reaction with the base and then HCl. So what is happening here also? This H2SO4, it is replacing, and then what is happening? Concentrated, it is displacing the volatile acid from their salt. Means what? If this is the salt, this H2SO4 is replacing them, and at the end whatever is formed is the HCl. Similarly, if you see the HNO3 reaction, children, what is happening there? See, NaNO3, ultimately you all know that if you see here, this is a salt that has been formed when HNO3 has been reacted. Okay, so what is happening when an HNO3 acid, suppose it reacted with, suppose a base that is NaOH. So what was formed? What was formed was NaNO3 plus H2O. Okay, so what do you see here? My base, the base which was there in the production of NaNO3 was NaOH, and the acid that was involved was HNO3. Now this NaNO3, when this is being reacted with H2SO4, then here also the same thing is happening, children. This HSO4 minus, this is forming a compound with Na, and then the parent acid which was there, that is being liberated separately. Okay, so this is one of the reason why concentrated H2SO4, it is being used in the preparation of HCl and HNO3, because if we are taking the salt of that particular acid and we are reacting with H2SO4, then the particular acid is being liberated. If it is nitric acid, it is being liberated in vaporized form. Alright, so this is also an important thing, children, and the question that you can be asked related to this is that why is concentrated H2SO4 used in the preparation of HCl and HNO3, and your answer will be because sulfuric acid displaces the particular acid or the volatile acids from their salt. Alright, so this is the thing where it is acting as a non-volatile acid. Now moving on to the next thing, children. The next thing is that the chemical properties of sulfuric acid, in which sulfuric acid is acting as a oxidizing agent. Okay, so when we talk about oxidizing agent, what does this mean, children? It means that it is getting reduced, and then that is why it is oxidizing the other thing with which it is being reacting. So this is an oxidizing agent. So what is happening? It's a very strong oxidizing agent, children, and then what is happening? Oxidation reaction involve addition of oxygen, because you know that whenever oxidation is taking place means what? That oxygen is being added, and or else what is being removed? Hydrogen is being removed. This is what oxidation reaction is. Now the oxidizing property of concentrated sulfuric acid is due to the fact that H2SO4 on thermal decomposition yields nascent oxygen which helps in oxidation. Now what is nascent oxygen, children? It can be described as a free oxygen which is there. Okay, and then what is happening? Since this free oxygen which is there, so it's there in your book, it goes like this, children, that H2SO4 upon heating, what is happening? Thermal decomposition takes place. So when we talk about thermal decomposition, means what? Heat is being applied. So it is giving me what? It is giving me H2O, then it is giving me SO2, and then what is being liberated? This is called nascent oxygen, children, this particular oxygen. And then you all know that what happens in oxidation process, that oxygen is being added. So when I talk about oxidation process, so suppose Cu is reacting with H2SO4, then this particular oxygen, this is the nascent oxygen that is being reacting, so this is forming CuO. Okay, so what is the net reaction that is taking place, children? I'll tell you that H2SO4 CuO, okay, plus H2SO4, this is giving me what, children? This is giving me CuSO4 plus H2O. Okay, so first of all, what is happening? The nascent oxygen that is there, that is reacting with Cu to form CuO, and then what is happening? This CuO, this is reacting with H2SO4 to form what? Copper sulfate and then water. So the net reaction is what, children? The last reaction, if you see, we are adding up both of them. So Cu plus 2 times of H2SO4 is giving me CuSO4 plus 2H2O, that is copper sulfate, plus 2 times of water, 2 molecules of water plus sulfur dioxide gas is being liberated. So if the question is being asked, children, that explain how is sulfuric acid acting as a oxidizing agent, then what you will be writing? You will be first writing that how H2SO4 is being broken down as H2O and sulfur dioxide, and then there is a nascent oxygen, and this nascent oxygen is being responsible for oxidation. Okay, so this is another thing which is there, children. Now we'll be moving to the next point. So the next point is what, children? Oxidation of non-metals. That how is, first of all, sulfuric acid is acting as an oxidizing agent. Then we will be studying that how is oxidation of non-metals taking place. Then we will be studying about the oxidation of metals and then inorganic compounds as well. Okay, so what is happening, children? First, if we talk about the non-metal, suppose I am having carbon over here. Okay, so when this is being reacted with H2SO4, of course the balance reaction you should know. Then what is being liberated is carbon dioxide. What is being liberated is water, and then what is being liberated is sulfur dioxide. This is the reaction which is taking place. Okay, and then you know that how is oxidation taking place? This is with the help of the nascent oxygen that is being formed. So if you want to balance this becomes 2 times, this becomes 2 times, and this is also 2 times. So this is the reaction. Similarly with sulfur, if it is reacting, children, what is being formed? So sulfur, when it reacts with 2 times of H2SO4, it will be forming what? First it will be forming SO2, then it will be forming 2H2O, and then again 2 times of SO2. Now what is happening, children? This SO2 and this SO2, these are combining to form 3 times of SO2 plus 2H2O. Okay, so what is being formed here, if you see, the element whichever is reacting, the non-metal which is reacting, the oxide form of that is being formed because this is an oxidation process. And in the side, what is being released is water and sulfur dioxide. These are acting as the side product. Okay, the element which is there, the non-metal which is there, it is getting oxidized, and the side products that are being formed is hydrogen, water and sulfur dioxide. Now we will see what happens when it reacts with metals. So the metals, if I talk about, suppose this is Cu and suppose this is reacted with H2SO4. Then the same thing is happening here, children. The end product is going to remain same, that is my water and sulfur dioxide. But here, instead of oxidizing, what is happening? This is being converted into salt, that is CuSO4, and then the rest of the product remains same. So what is the difference that you see between metals and non-metals, children? In the metals, the salt is being formed and the end product are, and the side products are water and sulfur dioxide. Now in the non-metals also, the side products are water and sulfur dioxide, but the main product that is being formed is the oxide form of the metal. And in non-metal I am getting the salt form of the metal. Okay, in metal I am getting salt form, in non-metal I am getting the oxidized form. Then we'll be seeing the, similarly there is Zn reaction, children, where when Zn is reacting with H2SO4, it is giving me zinc sulfate, that is a salt again, and the side products are what? Water and sulfur dioxide. In the non-metals we are getting 2 molecules of sulfur dioxide, and in the metals we are getting only 1 molecule of sulfur dioxide. Alright, then we'll see that how is H2SO4 reacting with the inorganic compound. So what are the inorganic compounds, children? The inorganic compound here is, suppose the example that has been taken is hydrogen iodide. So Hi, when it is being reacted with concentrated sulfuric acid, what is being liberated, children? The sulfur which is there, it is getting liberated, and then the side products continue to remain the same. Okay, similarly when hydrogen sulfide is being reacted, children, what is happening? Now important part in all of this is, children, is that whatever sulfuric acid that we are taking should be in concentrated form. So here also sulfur is being liberated, and then what is liberated is 2 times of water and sulfur dioxide. So here also what is happening, children, in all the three cases, the side products that we are getting is water and sulfur dioxide. That is an important thing. And further what is happening, based on whether it is reacting with a metal or a non-metal or a inorganic compound, the products are different. If it is a non-metal, we are getting oxygen form. If it is a metal, we are getting salt form. If it is an inorganic compound, we are getting sulfur is being liberated. Whatever the compound is there, apart from the hydrogen, that particular ion is being replaced, or this is being liberated, not replaced. Okay, so this is the thing what is happening when we are reacting the concentrated sulfuric acid with different, and this is the way the sulfuric acid is acting as an oxidizing agent. Now what is there, children? The properties of the sulfuric acid as a strong dehydrating agent. Okay, so how does it act as a strong dehydrating agent, children? Because we have seen also when we just saw the process of production of sulfuric acid, there it was acting, there it was used to absorb the moisture. Okay, so we'll be seeing quickly that how it is acting as a strong dehydrating agent. Concentrated H2SO4, it removes the elements of water due to strong affinity for water. Of course, when it is absorbing moisture, children, it does means that it is having very strong affinity with water. So that is what? That is hydrogen and oxygen in the ratio 2:1 from carbohydrates, organic compounds, etc. Okay, now concentrated sulfuric acid also removes water of crystallization from hydrated salts. So you know what is water of crystallization. So even concentrated sulfuric acid has an ability to remove that water as well. Okay, and then the third point, if you see, the concentrated H2SO4 is also acting as a drying agent. Why is it acting as a drying agent? Because it is capable of absorbing all the moisture which is there. Okay, now it dries the gas such as it can dry nitrogen gas, children, oxygen, it can dry chlorine, sulfur dioxide and other things which are there. Okay, and what happens, we are having separate gases, that is hydrogen sulfide and ammonia. It reacts vigorously with concentrated H2SO4 and therefore they are not dried. So what is happening, children? If the question is being asked that name two compounds which are not being dried by concentrated sulfuric acid, your answer will be hydrogen sulfide and ammonia. Okay, so what is a drying agent, children? It brings about a physical change with no change in composition of the compound, and dehydrating agent is what bring about a chemical change and a change in the composition. Okay, drying means what? You are just extracting the water from it, and when we are dehydrating, children, then there is a change in the composition of the compound as well. Okay, so this is a table that has been given. We'll be seeing that how it is acting as a dry agent form a glucose. So you all know that glucose is what, children? C6H12O6. So whenever we are passing H2SO4, what is happening? The end product what I am getting is 6 times of carbon, and then this 6H2O is being dehydrated. So this is the dehydrated one, this is being removed. Okay, that is the dehydrating agent. So what is being left? Only 6 times of carbon. When we talk about cane sugar, children, which is also called sucrose, that the formula goes like this. What happens whenever we are passing H2SO4, and mind it, children, it has to be concentrated. Then it is remaining, what is remaining is only 12 times of carbon. And the 11 molecules of water is being dehydrated. It's being removed. It's being absorbed by the concentrated sulfuric acid because it is having very strong affinity. Okay, then we move to the next one, children. Similarly, what is formic acid? If you know the acid that's been found in ants. So this is when we are passing concentrated sulfuric acid to this, what is being liberated is carbon monoxide, and the water part which is there, it is getting dehydrated. Means what? It is getting absorbed. The sulfuric acid, it's having high affinity and therefore it is getting absorbed. If you talk about ethanol, children, ethanol goes by the formula, this is ethyl alcohol. So this is when you are passing concentrated sulfuric acid, what is happening? First of all, the hydrogen which is there, that is being absorbed, and you are left with what? You are left with only ethene, that is also called ethylene. Okay, so this is the end product. So what is happening, that whenever you are acting concentrated sulfuric acid, all the water which is there in the compound, this is being absorbed. So this is also known for absorbing the moisture. Okay, so here if you see hydrated salt, copper sulfate 5 water means what? This is a hydrated salt. Okay, copper sulfate When we talk about hydrated copper sulfate, that is written like this, 5 times of H2O. So what is happening when we are passing it through concentrated H2SO4, the water of crystallization which is there, this 5H2O, this is being removed, and then what am I left with? We are left with only copper sulfate, which is white in color, and it's anhydrous. When we talk about anhydrous, it means what? It is completely dry. It is not having any water molecule. Alright, so this is the thing, children, how the things are being carried out. If you see, these are the crystal of sugar. Concentrated sulfuric acid is being acted on this. Then what is happening? Steam is being evolved, and black spongy cad mass of carbon is being liberated. Means what, children? The 6 molecules of water are being removed in the form of steam, and what are we left with? Only black charred mass of carbon. Okay, so these are the observation which are seeing. Means suppose in a beaker, if we are taking sugar, okay, and if we are just pouring, children, concentrated sulfuric acid, then what will happen? The entire water molecules which are there, they are going to dry up, and then we will be left with a black mass, that is of carbon. Okay, so this is an important concept, this you should know. And then the question that can be asked is, explain with example the dehydrating nature of sulfuric acid, concentrated sulfuric acid. Moving on to the test for sulfuric acid, children. So here what is happening, that how are you going to carry out the particular tests which are there. Then what is happening, in the first we will be discussing about concentrated sulfuric acid, and then we will be moving to the diluted one. Now here what is happening, children, whenever copper is being reacted, okay, suppose for example whenever copper is being reacted with concentrated sulfuric acid, okay, and then ample amount of heat is being given. So we have just read this, children, what is happening whenever a metal is being reacted with concentrated sulfuric acid, the salt is being formed. We have studied this already. And then what is being released is water, and then what else is being released is sulfur dioxide. Okay, then what is happening, children? Here they are saying what? The SO2 which is there, the sulfur dioxide which is there, this is being evolved. Okay, similarly what is happening, children, whenever we are reacting a salt, suppose NaCl, if we are reacting with H2SO4 and you are providing an ample temperature of greater than 200 degrees Celsius, the salt of this particular salt, so this is already a salt, and then it is also forming another salt, this is NaHSO4, and here HCl gas is being released. So we already studied this, children, that H2SO4 has a capacity to replace the parent acid which is there, and hence it is used in the formation of, or in the preparation of HCl and HNO3. So here what is happening, in the first reaction what is being evolved? Sulfur dioxide is being evolved, and in the second reaction here hydrogen chloride is being evolved. Okay, so this is being happening, children, that whenever test for SO2 is done, how? Whenever we are adding the acidified K2Cr2O7 solution. So what is happening? Orange to clear green. So this is the color change that is happening. And for HCl what is happening? The dense white fumes. That how can you know that HCl gas is being evolved? So what is happening? Whenever here, if you are taking a rod which is dipped in the ammonia solution, okay, so when HCl will be reacting with ammonia, it will be giving what? The dense white fumes of NH4Cl, okay, the ammonium chloride, and that is being released. So that is a test that HCl is being released. And how can I test that sulfur dioxide is being released? For that I will be taking acidified K2Cr2O7 solution, and what is happening? If it is turning orange to green, then I can say that sulfur dioxide gas is being released. So this is what is happening when I am reacting concentrated sulfuric acid. Now what, children, we will be moving to what happens when dilute sulfuric acid is being added. Okay, so which test it is giving? So whenever we are reacting barium chloride with dilute sulfuric acid, children, so this is my barium chloride. If I am reacting with dilute sulfuric acid, what is being formed? HCl is being formed, of course, and then the white precipitate of barium sulfate is being formed, and this white precipitate is being released, which is there. And then how can you test whether BaSO4 is there? Then for BaSO4, what the test is there, children, if you just have a look. So how to see, first of all, the BaSO4 white PPT, so BaCl2 solution, it is reacting to give a white PPT, but then with dilute HCl or dilute NaCNO3, no white PPT is produced. Okay, so that is the reason that this is the way you can conclude that BaSO4 is being released. Okay, because it is forming white precipitate only when it is reacting with H2SO4, and when it is reacting with dilute H2SO4, and when it is reacting with dilute HCl or dilute HNO3, whatever the chloride form or the nitrite form is being formed, they are soluble in dilute H2SO4, so no such precipitate is being formed. Okay, so if you are getting the precipitated form, means what? BaSO4 has been formed. And when you talk about lead nitrate, children, this is PbNO3 twice. When this is reacted with dilute form of H2SO4, it is forming what? It is forming my nitric acid, and then the precipitate of lead sulfate is being released. And then how is it possible, children? Because lead sulfate is insoluble in hot water even if it is being heated. Okay, so what is happening? The things which are there here, children, see. So however, obtained on heating, the lead nitrate with dilute HCl is soluble in hot water. So dilute sulfuric acid and dilute hydrochloric acid can hence be distinguished using lead nitrate solution. Okay, so what is happening? The lead PbSO4 which is there, children, it is insoluble in hot water even if we are heating it, this PbSO4 when we talk about. But then when we talk about PbCl2, which is formed upon reaction with HCl, whatever we are getting is PbNO3 twice. Okay, so what is happening? The form which is there, it is soluble in hot water. So this is also a test how you can distinguish between H2SO4 and HCl. Okay, so these are the tests to distinguish between H2SO4 from HCl and HNO3. And we also discussed about BaSO4, children. What happens for BaSO4? BaSO4 is forming precipitate only with dilute sulfuric acid, and it is not forming any precipitate with HCl or HNO3, because whatever the chloride or the nitrite form that is being formed, it is soluble in dilute H2SO4. So these are the tests for sulfuric acid. Now we will be moving to the use part, children. So what are the uses of sulfuric acid? It is used as a fertilizer, it is used as a fiber dye. So these are the table which is given, and explosive and acids as well. Okay, so as a fertilizer, it is used as NH4 twice. So this is ammonium sulfate, and then it is also used as fiber in the form of rayon and nylon, which are artificial fibers. And dyes and drugs, it is used from coal tar derivatives. Okay, now what is the next thing, children? Explosive, that is TNT. This is trinitrotoluene, that is a very dangerous explosive, children. So it is being used, sulfuric acid is being used in the formation of that as well. And then we have picric acid and trinitroglycerine. Now in case of acids, we know that if we want to, we just studied that if I want to form nitric acid or hydrochloric acid, then what is happening? The hydrogen chloride gas is being formed, or hydrogen chloride acid is being formed, or nitric acid is being formed. And of course it is also used in making half phosphoric acid, that is H3PO4 as well. Now if I talk about the general uses which are there here, H2SO4 is used in purification of oil products like petrol. So if I want to purify the petrol which is there, I can use H2SO4. Now as a pickling material, it is removing metallic impurities from the surface of metal. So what is galvanizing, children? So in the process of galvanizing we are using zinc, and then before the process of galvanization, if I want to remove the metallic impurities, then I can just use H2SO4 for removing them. Okay, and in lead accumulators, what is happening? H2SO4, it undergoes electrolysis and hence it is used in storage batteries. Then in preparation of iodine, it is used in the preparation of carbon monoxide, hydrogen gas and hydrogen sulfide. From among this, how is it used in the preparation of iodine we have studied, and in the preparation of H2S also we have studied, children, that how iodine is being reacted. If you remember, when we are just acting 2 times of hydrogen iodide, if it is reacted with concentrated sulfuric acid, what is being released? I2 is being released, and then 2 times of H2O and SO2. This is the reaction which is there. So iodine is being formed. When we talk about sulfur, children, if you remember, the sulfur, how is it being prepared? When hydrogen sulfide gas, it is being reacted with sulfuric acid, of course the concentrated one, then sulfur is being produced. So these are the compounds which can be produced from sulfuric acid. Okay, now moving to the next part, children, this is the last part. So oxidation and reduction reactions which are there, children, if you see, addition involves what? Addition of oxygen. So whenever you are, these are the simple reactions which are there, children, which hasn't got anything to do with sulfuric acid. So when we talk about addition reaction, means what? Addition of oxygen, children. Okay, so when suppose I am taking 2 times of Na, okay, or 2 times of Ca, plus if I am adding O2, this is giving me 2 times of CaO. So this is my addition reaction. And when we talk about removal, children, what happens? See, H2S gas, when it is removed acting with Cl2, it is giving me 2HCl plus S. So this is a example of removal reaction. So these are the things which is happening, children, in this oxidation. And then reduction involves what, children? See, first of all, when we talk about oxidation, okay, this table is all about what are the differences between the oxidation and reduction, children. So when you talk about oxidation, it involves addition of oxygen, and in reduction it involves removal of oxygen. Then in oxidation, hydrogen molecules are also being removed, and in reduction, hydrogen atom which is there, that is being added. Then what is happening? Similarly, addition, removal, loss, other things have been given. So you just go through the table so that you can know that how oxidation and reduction can be distinguished. Now what is an oxidizing agent, children? Oxidizing agent are the substances which bring about oxidation, and then they themselves are getting reduced and they are oxidizing the others. And similarly, if we talk about reducing agents, these are the substances which bring about reduction by getting self-oxidized. Okay, so these are the things, children, the examples has been given, which are all acting as an oxidation, which are all responsible for oxidation, oxidizing agents, and these are all reducing agents. Now the things which are there, children, if you just see, the table is giving. So if we talk about this sulfuric acid, then what is happening here? If you see, whenever here HNO3 is being acting as an oxidizing agent. Okay, and what is being formed here, you all can see. So you can just go through this table for reference, although it's not there in your main sulfuric acid part. But then if you want to understand the exact difference between oxidation and reduction, you can just go through this table. Alright, student, now this chapter has been done. So we will be discussing more about this in the class. Any doubts which are there, you are free to ask. Okay, alright, thank you, students.